Hello, this is section 2.4. We're going to finish it in one video, and this will be the final section of material that will be on your first unit test. Okay. So today is Thursday. Tomorrow, being Friday, we will just use that day as a catch-up day. You can spend the time working on your homework assignments or asking questions. I'll look at the assignments and pick the one that was that most people had a struggle with, and we can go over that as an example. So we are finishing / continuing talking about linear functions and other linear equations, specifically slope. Don't forget, today is Thursday. Pick up your book. Just bring your ID, go to the school. I think I said between 12 and 5, and your book is there waiting for you if you haven't picked it up already. Okay, so applications of slope. Again, you've seen this before. Two linear functions are parallel to each other if they have the same slope. This if and only if statement is a very handy mathematical phrase, and it splits up the sentence into two sides, the left side, what comes before it, and what comes after it. And if you have this if and only if, it's reversible. So that means if two slopes are the same, then the two lines are parallel. It also means that if two lines are parallel, then their slopes are the same. So it's like it's kind of like an equation sign. So two lines are parallel, they have the same slope, and if two lines are perpendicular, their two slopes are what are called opposite reciprocals. So one slope is really equal to the opposite of the reciprocal of the other slope. Let's put that into action. So I want to find the equation in general form of a line that is perpendicular to this line that has a y-intercept of a crazy y-intercept, 0, negative 100. Okay, first of all, general form is what Algebra 1, what is also known as standard form. But general form, I looked in the text because you need to know how MyMathLab will accept correct answers. And it's written like this: ax plus by plus c equals 0. And as long as a, b, and c are all real numbers, then it's a line. Where both a and b can't both be 0, because then you would get a false statement, because then you would have something like 8 equals 0, which is not even true. So at least a or b have to be non-zero. So our final goal, it's good to know what our final goal is. We need to get a linear equation in this form. And the linear equation has to be perpendicular to this, and it also has to go through the point 0, negative 100, which happens to be the y-intercept. Now, to be perpendicular, how am I going to find that? Well, I know it's perpendicular to L1. So I'm going to find the slope of L1. And then, like I just thought about, once I have that slope, I'll just take the opposite reciprocal and I will have our slope. So let's get to work. First of all, let's figure out this slope. And by counting, I find integers, integral ordered pairs. Here's one right here. It looks like I go down 1 over 2, and again, down 1 over 2. It's slanting downward, so of course it's negative. How negative is it? It goes down 1 every time it goes over 2. So the slope is negative 1/2. What does that tell us about our slope? Well, I'll take the opposite of this, so now it's positive 1/2, and then reciprocate that, making it positive 2. So the slope of our line will be positive 2. And now I know a lot of really useful information. I know our slope, and I know our y-intercept, so I can immediately put it into slope-intercept form. Y equals 2x minus 100. But it was asking for the general form, so I just had to make this into ax plus by plus c equals 100. So that's just a matter of subtracting 2x and adding 100, and I'm done. This is what your book says about the general form, page 262 if you're interested. Next example, find another linear equation, this time in slope-intercept form, that has to be parallel to this. Parallel to this, and has the same y-intercept as this monster. Goodness knows what this looks like, but I don't need to know what it looks like, because all I need to do is find this guy's y-intercept. And our line has the same y-intercept as this. Well, how do I figure out this y-intercept? The same way you find literally every single y-intercept, you simply let x equal 0. So you plug in 0 for x, so you find f of 0. And for this case, f of 0 equals the square root of 0 to the 5th plus 9. Don't need a calculator for this because 0 to the 5th is just 0, plus 9 is 9. This is 3 minus 2, which is 1. F of 0 equals 1. So 1 is this function's y-intercept, which means it's our y-intercept. Now, what is our slope? Well, our slope is the same as this line's slope because our line is parallel to this line. So I just have to find this guy's slope, which means there's probably 100 different ways to do this, but the easiest way and most straightforward, we do solve for y. If I solve for y, I'll put it in slope-intercept form, and I will know the slope. So I'm going to
Did you get the salty tortilla chips?
so you subtract 3x, add 19, and then I'll divide by -2, and I get the slope is positive 3/2. The y-intercept is something nasty, but I don't care about this y-intercept. I just care about the slope. And since this line has a slope of 3/2, I know that our line has a slope of 3/2 because we're parallel. And I already figured out the y-intercept over here. So I've got my final equation. Y equals 3/2 x plus 1. Final answer. And all the work above it supports this. Just a couple more slides. Don't let this one scare you. We want to find an equation of a line that's perpendicular to this. Now, what does x equal 9 look like? X equals 9, that's a vertical line. It's telling, remember, these linear equations are telling you the ordered pairs that are on this line. This linear equation is telling you ordered pairs that are on this line, but it's much more hidden. You need to figure out, or all the ordered pairs that are on this line are all the combinations of x, y, such that 4 times the x value minus 5 times the y value plus 1 equals 0. So can you in your head find an ordered pair where 4 times the x minus 5 times the y and then add 1 and you'll get 0? I can't. Maybe 0 and 1/5 would work, but you really have to kind of think about it. This one, not too much thinking. This one's very, very simple. It just says x equals 9. Well, I can find an ordered pair, 9, 3. Here's another one, 9, 4, 9, 5, 9, 6, 9, 100. All those ordered pairs have x equals 9. And if you were to graph them, you would get a vertical line. So x equals 9 is a vertical line. And I need something that's perpendicular. Well, if it's perpendicular to a vertical line, that must be a horizontal line, which is just y equals a number. And I want that horizontal line to go through this ordered pair, which is -7 to the left, but 18 up. And since it's a horizontal line, if it has to go through 18 as a y value, then that is the equation, y equals 18. Y equals 18 is just a flat horizontal line, and it's definitely going through -7, 18. It's also going through -8, 18, -9, 18, etc. Similar problem. Find a line that is parallel to this, so another vertical line that goes through this. So if it's parallel to this, so this is where it gets a little slippery. I really can't say that it has the same slope because vertical lines don't have a slope. And don't be tempted to say that the slope is 0. That's not correct. 0 is a real number. It's a wonderful number. But vertical lines do not have a slope. There's no number that can represent the slope. But vertical lines are all parallel to each other. So if I want a line that's parallel to this vertical line, it just has to be another vertical line. So is it x equals 5 or x equals 1 or x equals 2? What vertical line will work? Well, I need the vertical line that goes through -7, 18. So the vertical line has to be x equals -7. That vertical line shoots through -7, 18. It also goes through -7, 19 and -7, 20, etc. What is a line? What is a linear equation that's perpendicular to this but goes through this ordered pair. And you're going to give me the answer in all three forms: slope, intercept, point slope, general form. So perpendicular to this line, so I need to find the slope of this line and then get the opposite reciprocal, and that will be my slope. So that's the first thing we should do. So find the slope of this line. So I want to solve for y. Subtract 4x, subtract 1, then I get this. Divide by -5, and I get a lot of fractions here. The -4 and the -5, those two negatives cancel out, and I get 4/5 x plus 1/5. The plus 1/5 is a y-intercept. This does not concern me. The slope is all I really care about. The slope of this line is positive 4/5, up 4 over 5. And our line has to be perpendicular to that, so our slope will be the opposite reciprocal of this. So -5/4. And the easiest way is to start with point slope form, because I have the slope and I've got a point. So I can just identify point slope form right away. Y minus the y value, so y minus -9 equals the slope times x minus the x value, so x minus 1. Y minus -9 is the same thing as y plus 9, so you might as well write that. And this is it. This is a linear equation. It's in point slope form. Don't forget these parentheses. Without these parentheses, it's incorrect. And don't distribute the -5/4 because you're getting out of this form. And plus, it's more work for you anyway. Another chance to make a mistake, so don't even do it. For point slope form, I mean. But to convert this to slope intercept form, you will have to distribute -5/4 because we want to solve for y. So I would distribute -5/4, and -5/4 times -1 is +5/4. And then I just subtract 9, giving me this, -5/4 x minus 31/4. So here's the y-intercept. These two lines look different, but they are identical. They are the exact same line. This line right here has a y-intercept of -31/4, just like this one. And then to make it into general form just needs everything on the left side of the equation with 0 on the right side. So it's just 2 steps. Add 5/4 x, add 31/4. That should be sufficient because according to the book, you've got A, B, and C. They're all real numbers, so you should be fine. But some publishers and other authors maybe want all integers, so you could just multiply everything by 4 and get this. But this one should be sufficient unless otherwise stated. Three more slides. Let's talk about what the slope actually means. Don't forget to pick up your book today between 12 and 5. Pick up your book. What is the actual meaning of a slope? Well, the slope is it's this constant rate of change. It's the way a line changes, but it changes this at the same rate all the time. And you are bombarded with this in your life all the time. Lots of things are related in a linear way. For example, let's say you got this simple equation that's in slope intercept form, and let's let y represent the total money you have, and x represents all the hours that you work. So what does 13 represent? The slope. Remember, slope is the change in y compared to the change in x. So money compared to hours. Well, 13 must represent how much you get paid per hour, $13 per hour. This phrase, $13 per hour, there are two variables at work, money and time, because it's a ratio comparing two things, $13 per 1 hour. Another one, let's let y represent all the money you spend, and x is how many gallons of gas that you pump. What does this slope represent? Well, again, you're comparing money to gallons of gasoline. This is the rate of the price of gasoline. It's $2.91 per gallon. Two things, money and gallons. Ratio is a comparison of these two things. This one, Y is the distance you are from home, and X is how long you've been driving. So compare this Y value, distance, to time. What happens when you get distance divided by time? What do you get? What is that ratio? Distance divided by time is speed. So 40 must represent your speed. You are traveling at 40 miles per hour. Two things, miles and time. So distance and time, ratio of two things. But not everything has a constant rate of change. Parabolas, and actually, almost everything doesn't have the same rate of change. That's why lines are so special. Almost every other function has a rate of change that is always changing. This parabola, the y values are increasing, but then when you go over the vertex, suddenly the y values are decreasing. So this would be like having a job where the first few hours you're making money per hour, but then after a certain amount of time goes by, you start losing money. That'd be a crazy job. So it's not, a parabola doesn't have a constant rate of change. Its rate of change is always changing, but you can still find what's called an average rate of change. And we'll get back to this in a second. The average rate of change is just like the slope, but instead of y2 and y1, we just replace y with f of x. But f of x is the same thing as y anyway. But saying f of x allows us to use any function we want. And I want to use this function, this parabola, and I want to find the average rate of change between x equaling 2.5 and x equaling 3.1. Remember, there's no such thing as a constant rate of change here because this is not a line. So I need to find the average rate of change between these two things. So I just need to find what are the y values at these two particular points. And then I'll just kind of like find the slope of that. I'll use that to find the slope. So I need to find one y value, subtract the other y value, and then divide that by the difference of the two x values. So I don't show my work here, but I just plug in 3.1 into here, and I got negative 5.42. I plugged in 2.5 into here, and I got negative 3.5. You subtract these, I go to my calculator, I discover that that's negative 1.92, divide by 0.6, and I got this. So what does that mean? That means this parabola, as it moves from x equaling 2.5 to x equaling 3.1, the y values on this parabola will decrease at a rate of 3.2 units per x unit. This is our last slide, guys. So here's a little bit more color to that explanation here. This is that parabola that we just talked about. And here are the two ordered pairs. 2.5 produced negative 3.5, and 3.1 produced negative 5.42. So what is the average rate of change between this point and this point? That's the same thing as asking for what is the slope of the line that goes through these 2 points? And the slope of the line that goes through these 2 points was negative 3.2. So what can we understand about that in terms of the parabola? Well, if the parabola represented, like if the y values represented money and the x values represented time, then that means that between the hours of 2.5, like 2:30, I don't know, and the hour of 3.1, we were losing $3.20 per hour. Don't forget, you can't just say we are losing $3.20. That is not the case. You're not losing $3.20. You're actually losing $1.92. But you only lost $1.92 compared to this movement of the x values. So when you compare these two values, you get this ratio. This is negative 3.2 over 1. So the rate that you're losing is you're losing $3.20 per hour, which is the same thing as losing $1.92 for every 6/10 of an hour. So that's what this average rate of change would mean. You're losing 320 per hour. Or if Y represented the amount of volunteers and X represented the amount of degrees in the room above 70. Okay, so let's say, so 2.5 means it's 72.5 degrees, and 3.1 means it's 73.1 degrees. Well, what is happening to the volunteers between the temperatures of 72.5 degrees crawling up to 73.1 degrees? Well, you're losing 3.2 volunteers every, don't forget the X value, every 1 degree you add. You're basically losing 3 volunteers every degree. But that's not true for the whole thing, because otherwise it would be a line. That's only true between this point and this point. And then one last thing, I can't help myself. If I said, find the average rate of change from this ordered pair to, oh God, this ordered pair. Oh, come on. Oh boy, about to give up here. Sorry. Hopefully you're laughing over there. All right, so from this ordered pair to this ordered pair, you can imagine a line going through this, and this line is angling upwards, so it has a positive slope. So in the volunteer situation, if I found this rate of change, I could say that, well, between this X value, so this degree added to 70 degrees, all the way to this degree added to 70 degrees, the amount of volunteers were going up a certain amount per degree. I'd have to find the actual slope to give you the actual number, but that would be the meaning. All right, pick up your book. I will see you tomorrow. No, yeah, I'll see you tomorrow. Friday will just be a work day that you get a chance to catch up on some homework and ask questions.